Greetings, this is Mark Anderson for Kellogg Community College, and this is my introduction to series. And what a series is the number of terms in a sequence added together, or the sum of the terms in a sequence. And I want to first of all start to talk with you about what sigma, or summation notation, does and what it represents. There's a couple things. First of all is the Greek letter sigma, and this is to denote that we will add all of the terms that we are told to add in this sequence here, and the sequence is going to start with the first term. This lower part here will tell us which one we start with, and for the most part we're always going to start with the first term, and then we are going to finish with this number on top. So this would be that numbered term. So, for example, this would be from a sub 1 through a sub 4. It is coincidental that, if we start with 1, this is going to be the number of terms. But when we don't start at 1, this top number here will tell us which number we finish at. So I just want to do a quick example with you here. The sum of the first, this is really saying I want the sum of the first 4 terms generated by the equation of 2n. So we're going to figure out what a sub 1, a sub 2, a sub 3, and a sub 4 is. And then we're going to add these all together. So 2 times 1, which is 2, 2 times 2, which is 4, 2 times 3, which is 6, and 2 times 4, which is 8. And then we would add all of these together. This is the sum of the first 4 terms from the first term through the 4th term of this sequence created by the equation 2n. So 2 plus 4 plus 6 plus 8 is 20. So the answer to this problem is 20. These patterns here have to be done brute force, which means we're going to have to do each term one at a time, and then add them all up. Since they don't necessarily follow one of the arithmetic or geometric patterns that we're going to be learning in the next 2 videos through 3, 4, 5 videos, these just have to be done brute force. So I'm going to plug 1 into this equation, so because we're going to need 6 terms here, so this is going to be a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. And we add all these up, and we get an answer of what we have for this series. This series is going to be the summation of the 6 terms in this sequence. So 1 plus 3, that's 4. Let's see, 2 plus 3, that's 5. 3 plus 3, that's 6, and you can see that the pattern would continue by adding 1 to each of these numbers, all the way to the 6th term, or a sub 6, which would be 6 plus 3, which is 9. So 4 plus 5 plus 6 plus 7 plus 8 plus 9, if I carefully added those, I get an answer of 39. Now for this exponential pattern here, I'm going to change this, instead of the corner number, I'm going to change the base from 1 through 4 for the first 4 terms, so this would be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. If I add all 4 of these numbers together, I get an answer of 100. Alright, so moving on to my next example here. Alright, that's a good stopping spot. Alright, getting my pen ready. Alright, so in this case, I'm going to change the exponent from the first through the 3rd term here. So this would be 3 to the 1st, plus 3 to the 2nd, plus 3 to the 3rd. So 3 plus 9 plus 27 makes a total of 39. 39 is right. Alright, so problem number 14. I'm going to plug in 1 through 6 for my letter I. And this is going to give me 2 times, and it's sometimes, since this is going to be a 6-term problem, I'm going to do this in my head. I'm going to do a little mental math here. I'm going to go 2 times 1. 2 times 1 minus 3 is negative 1 quantity squared. That's my first term of 6. Plus, I'm going to plug in a 2 here for my second term, so 4 minus 3 is 1 quantity squared. I'm going to plug a 3 in here, so 3 times 2, which is 6, minus 3 is 3 quantity squared. And you can see that the pattern is seemingly going to move up by 2 each time, so let's see if that theory is correct. I'm going to plug in a 4 here. 4 times 2 is 6 minus Wait, hold on. I'm going to plug in for my fourth term. This is 8. 8 minus 3, which is going to be 5 squared. And you can see that the next one would be 7 squared, and the last one would be 9 squared, because that would be plugging in 5 and 6 respectively. So let's see, I got 1 plus 1 plus 9 plus 25 plus 49 plus 81. If I add all of these together, I get an answer of 166. Okay, well, for my next problem, I'm going to plug in 3. Oh, wait. Plug in 3. Oh, this is interesting. See, in this problem here, I'm starting with the third term. I'm starting with a sub 3. And I'm going to go and stop when I get to a sub 6. So it's a sub 3, a sub 4, a sub 5, a sub 6. So there's my 4 terms in the problem. Now, a lot of people sometimes get this confused because they say, oh, well, the number on top tells me how many of them I need, quantity-wise. Well, no, actually, that tells you when to stop. So this stops at 3 and takes you all the way to 6. So it isn't 6 terms, it's 4 terms, because we're starting at 3 and ending at 6. So this is going to be 1 minus 3 divided by 3, which is going to be then negative 2/3 plus. And then I'm going to plug in my 4, and I'm going to go 1 minus 4 divided by 4, which is going to be negative 3/4 plus. Plug in a 5 there, 1 minus 5, which is negative 4 divided by 5. And the last one, 1 minus 6 divided by 6, so it's negative 5 divided by 6. If I add all these together and get common denominators, I get negative 61 over 20, which is the same thing as negative 3 and 1/20, or if you're using a decimal, negative 3 and 5/100, or negative 3.05. Wow, that's interesting. So let's take a look at this. This one's going to be a little bit longer because I'm going to start off with a sub 2. And that means I'm going to start by plugging in a 2 there. So this is going to be 3 times 2 squared plus 1. Start off with that. Plus, and then 3 times 3 squared plus 1. And then I'm going to go 3 times 3, 4. Oh, sorry, 4. 4 squared, not the other way around. 3 times 4 squared plus 1. All right, so there's the second, third, and fourth, and I need to get all the way to 6. So here we go. I'm going to have 3 times 5 squared plus 1. And then I'm going to go plus 3 times 6 squared plus 1. All right, and I do all this, I get an answer of 275. If I type this into the calculator, that will be pretty sweet there. Pretty sweet. Now, for my last set of problems here, I am not actually going to be solving for these. I'm actually just going to write these in something called expanded form. Now, what this means is that I am going to take these problems and plug one in for the letter I, in this case, simplify it as much as I can, and then write them out as to how many terms needed are in the problem. So in this case, I have I is equal to 1. So I'm going to plug in 1 in for my x to the first power, and 3 times 1, which is 3. And that's my first term. There's nothing actually more to simplify, so I'm going to go to my second term now. I'm going to plug in a 2 for my I there, so this would be x squared, and a 2 for my I here in the denominator, so that would be 6. Plus, I'm going to put a 3 in the corner, so this is x cubed, and then 3 times 3, which is 9. And then finally, the last one is x to the fourth power, and then 3 times 4, which is 12. And there is my expanded form by plugging in my letter number in for the letter I, and then doing some simplification. All right, problem number 18. I'm going to plug in 1 through 5 here, so this is 3x to the first power, which I wouldn't write the 1 there in my final answer. Then 3x to the second power, and there's nothing more to simplify. 3x cubed, 3x to the fourth, 3x to the fifth. That was pretty straightforward. Let's do this one down here. If I plug in 3 times 1, I get 3. And then x times 1 just gives me x. Plus, now I'm going to do 2. 3 times 2 is 6. X squared. Then I'm going to plug in 3, so that would be 9. 3 times 3, and x cubed. And then I'm going to plug in 4. 3 times 4, 12. X to the fourth. And here's my final problem of writing this, and this will end our video. To write a series in its expanded form, I'm going to plug 1 in for n. So this is 1 times, so I'm not going to really write the 1 there, and then this 1 plus 1 is 2. So 1 times x squared is just x squared, plus, I'm going to plug in a 2 here, so this is 2, and then 2 plus 1 is 3, so 2, this makes x cubed. Then I'm going to plug in a 3 for my n, and then 3 plus 1 is going to be x to the 4th. And then I'm going to plug in 4, and this would be x to the 5th power. All right, cool. There it is. There's my answer to that problem, and that is the answer to the video. Thank you for watching my little introduction to series, and stay tuned for my next video, which is going to deal with arithmetic sequences and series.